Hello everyone, and welcome to our group project. And we are excited to present our group project on language theory and automata. Our team consists of 3 dedicated members, myself, Rabah Fawaz Salali, and Biolina Helena, with valuable contributions from Jonathan. And this is our group project. So first of all, let's start with finite automata. We have here the start, the initial state where the process begins, and then S is the subject, B is the predict, K is information, and then O is the object, and then ACC is accepted state. So in the instructions, the automata accept SPOK and SPK, SPO, and finally SP. And then if you want to go direct to accept, we can do it because like this finite automata, that's why when we met S and P, that can go directly to accept. And then if you want to take SPO, pattern is also correct. So SPO and then accept, and then SPK and then accept is also correct. And then SPOK and then accept is also correct. And this finite automata accept these 4 patterns, but if it's just only S, you can't reach the accept state because it's not here. So for every transition from start to S, from S to P, P from O, O to K, you must input something like these. From start to S, you have to input one of these words to the terminal, like Rabab, Joe, Viu, Sarah, Kuchin, to go from start to S state, and from S to P, you must put one of these words, Mimasak, and Bilajar, and Main, and these words. So for example, if you add Fahad's name, so for example, here we have transition to move from start to S. So we have Rabab, Joe, Pius, Sarah, Kuchin, but we input Fahad's name, we can go to S because Fahad's name is not listed. And that's it for me, and we will continue with my group mate. And thank you so much.
Alright, Jonathan is here. Now I'm gonna explain about how to change the context-free grammar into the push-down automata. And the first one, we need to decide which one is the subject, predicate, object, and the information. So here we have the subject, which is consists of Rabab, Joe, Vio, Sarah, and Kucing. The predicate we have memasak, mengendarai, belajar, memakai, and main. The object we have makanan, motor, pemrograman, listrik, and bola. And the information we have di dapur, di jalan, di kamar, di mobil, and di taman. Context-free grammar is a language that can accepted by pushdown automata. So the first step, we need to create the statement first. We define the Q1, Q2, Q3, and Q4, and we define that Q4 is the final state. The first one, we create the transition from the start into Q1 and to Q2. There is lambda, and hashtag here. And from the Q2 into Q3, there are lambda, and S0. And then in the Q3, we have a lot of things here. The first one for the subject, we have lambda subject Rabab, lambda subject Pio, Joe, Sarah, and the last one is the subject is kucing. And for the predicate, we have memasak, mengendarai, belajar, pakai, main, and we write it like that. Lambda, comma P, comma the predicate. And the object, same as before, we lambda au makanan, lambda au motor, lambda au pemrograman, listrik, and bola. And same as before, we wrote the information, but we change it into K, which is in Indonesia mean keterangan. We have lambda K di dapur, lambda K di jalan, di kamar, di mobil, and di taman. Next one, we have the Rabab, Rabab lambda, Pio, Pio lambda, Jo, Jo lambda, Sarah, Sarah lambda, and so on until the last information, which is di taman, and lambda. And then from Q3 into the final state, into the Q4, we need to write like lambda, hashtag, and lambda. Alright, I think that's all about my explanation. Thank you.
Okay, so right now I'm going to explain about the push-down automata algorithm. So basically, push-down automata has a special feature called stack, and it saves memory of the alphabets that are already read. So here we uses the append method in Python. Okay, this is the class of push-down automata. It initializes automated state, stack, and starting state. And here, this is the initialization method. So here, it displays the list of possible states. And then here, the stack here initialized with the bottom marker hashtag. And then the starting state here is set to Q0. And this is the transition method. So it changes state based on current state here and input token here. And it updates stack and state according to defined rules. And it sets state to rich or reject if no transition rule matches. And this is the parser method. And this parser method processes a list of tokens. It calls transition for each token and ones with none to finalize. And it returns true if final state is accepted, but if it is not accepted, then it will return false. And here, this is the list of valid words. Okay, so basically in PDA, subject, predicate, object, and information here are the non-terminal variables because they can still be derived to these terminal variables here. And next is the recognize token method. Okay, so here it maps word to corresponding token S, P, O, and K. So in PDA, these tokens are the stacks, and it returns none if word is invalid. And this is the main function. Okay, so it prints the list of valid words here, so the user may know what to input to the terminal. Okay, and then next it takes sentence input, and it splits into words, and it converts words to tokens using recognize token method. And then here it prints error if any word is invalid, and here it creates push down automata instance, and it will check if the token sequence forms valid sentence, and it will print the validation result here. Okay, and lastly, it ensures main runs when script is executed directly. Okay, now I'm going to run a demo. Okay, so here. So first, let's try the ASP pattern, okay? Robot masak. Okay, so see, it is ASP and the sentence is true. Sentence validation is true. And then we tried the SPO pattern. Jo memasak or Jo mengendarai motor. Okay, so see SPO and the sentence validation is true. And then we'll try the SPK pattern. Rio belajar di kamar. Okay, it is true, SPK, and then we'll try the SPOK pattern. Sarah memakai lipstick di mobil. Okay, see, it is true as well. Now let's try if we input a word that is not in the list, okay? So let's try kucing, 9, ping pong, for example. It's not in the list, right? For ping pong here. See, it's none here. So it's missing, so that's why there is this output, invalid words. Please select the words from the list, okay? And if we enter just kucing, okay? Yeah, it is false because this PDA algorithm only accepts these four patterns. These four patterns: SP, SPO, SPK, and SPOK. So if it's just S, then is the sentence valid? The answer is false. Okay. That's the end of our presentation. Thank you for listening and have a great day.